I'm Renee Devereaux with the Club for Creative Expression, and today I have the honor of presenting to you Dr. Bryce Mander. He is a researcher and professor from the Department of Psychiatry and Human Behavior at UCI School of Medicine. Welcome. Thank you for being here. His research is concerned with characterizing the role of sleep in cognitive function and overall brain health across the human lifespan in both healthy populations and populations at risk for neurodegenerative disease. So his clinical research and focus has been on sleep disorders, Alzheimer's disease, and neurodegeneration. So my first question, please. So it appears that as we age, we seem to lose our ability to get restful, restorative sleep. Please give us a reason why that seems to be like an inevitable fact for the aging.
Yeah, of course. Thank you. First of all, Renee, thank you for having me on. It's a real pleasure to be here to talk to you about this. And I hope that the audience finds this enlightening. So that's a wonderful question. It's a central question that we're still trying to answer today. We've known that sleep quality changes across our lifespan, and in particular that sleep isn't as restorative or as restful. We've known that for decades and decades now, but there's very little we know about the mechanisms for that. What we do know, and this is, I think, a very fundamentally important thing to say, it used to be believed that if you're going to get older, your sleep is going to be terrible. Right?
That was the assumption.
And that's the assumption. But it turns out that that's not always true. Some people have better sleep than others as they get older.
Oh, there's hope.
So there's hope there, right? And the people who have the most struggle with their sleep tend to be people who have other medical comorbidities, particularly those that aren't treated. And there are certain sleep disorders that become more common as we get older, like sleep apnea becomes more prominent as we get older, and insomnia is another sleep disorder, becomes more common as we get older. But there are treatments for those.
And so I'm going after the source because that's, I'm always about prevention.
Yeah.
And so my thought is it hormones, the shifting hormones from, well, just the simple fact that our hormonal system just are not as efficient or effective as when we were young.
Absolutely. So that's a factor. It's not as well studied, but it's pretty clear from what we know right now that menopause and andropause as well in men both seem to influence sleep and make it less restorative and less effective. Other factors also impact sleep. So even if your sleep is typically healthy and restorative, the brain waves that your sleep experiences, right, the brain waves of your sleep is different as we get older. And that may be related to changes in the structure and the function of the brain itself. And that's something that we've been studying for the last, I would say, 10, 15 years now, is the role of sort of age-related changes in brain structure and how that may impact sleep expression. And so it turns out certain parts of the brain, the frontal part of your brain, for example, is very sensitive to age. And as that changes, as you lose gray matter or cell loss, as you lose white matter or glial cell loss, as that occurs, your sleep tends to deteriorate a little bit as well. And that actually has a functional role. It impacts cognition. But as you said, there's some hope, right? There are certain things that we can do to make our sleep better. And things like exercise, right? Exercise, if we exercise more and exercise regularly, our sleep will be better. We'll have more intense sleep and those brain waves will become more intense again. You may not sleep like you were when you were 20, but you'll sleep better than you were when you didn't exercise.
Okay, so no, that's important because I read that there are so many ill effects from lack of sleep. And for example, it weakens your immune system. And of course, the aging skin, it does age and it triggers stress, depression, anxiety. It kills sex drive. And the
make you look less attractive too, apparently.
Exactly. So the toxin buildup seems to be a factor. So also weight, obesity. I understand that there is a shift in the hormones, the leptin, less leptin, more ghrelin. And so what can we do?
Right.
Because I know that some of my clients are either on Valium and some are or take THC as opposed to CBD. CBD doesn't seem to be doing much for many people, but THC does. Now, have you done any research on On THC, that's the marijuana component that helps the people to relax and pass out.
Yeah. So there isn't that much literature on that, and part of that is because a lot of our research is conducted through federal dollars. Right? And certain substances, if they are illegal federally, even if they're legal on the state level, you cannot devote, it's a lot harder to get federal funds to investigate those. But the literature that we do have actually suggests that different substances like these, like marijuana use, whether it's THC or whether there's some CBD oil or whether it's actually just smoking or eating the marijuana directly, generally your sleep isn't better from that. It might sedate you, it might relax you, it might mellow you out, but the quality of your sleep isn't as restorative. And here's another example. A lot of people feel like they need a nightcap, right? To have a little alcohol before they go to bed, but that's not very good for your sleep either. It may knock you out, but it just sedates your brain. It doesn't make your brain go into a naturalistic sleep.
Correct.
And then halfway through the night, it clears from your system, and then you lose your REM sleep, and your REM sleep gets all disrupted.
Well, I understand there's also that blood sugar component, that your blood sugar elevates, and of course, then you're wide awake.
Yeah. And there's been this long-standing investigation into the relationship between glucose regulation or blood sugar regulation and sleep, and what sleep does to that. And just as you said before, there's a lot of ill effects of poor sleep. One of them is increases your risk for metabolic syndrome, increases your risk for weight gain if you do it for a long period of time.
Correct.
But then when that happens, right, when you have, say, maybe you've gained some weight, that actually can make your sleep worse as well, because you'll be at more risk for sleep apnea, which is obstructive sleep apnea. It's a sleep disorder where you have intermittent pauses in breathing while you sleep at night. And if you have weight gain, it can actually help collapse your throat and you have less muscle tone. And that can be bad for you for a number of reasons.
And so when there is these breaks in the breathing, and so you're actually depriving your brain from the oxygen.
That is correct. It's called hypoxia. So essentially your brain has intermittent periods where it's starved of the oxygen it needs to survive.
So then that would have another impact, like dementia.
Right.
And
yeah, that is absolutely correct. So there is now a fairly large epidemiological literature that suggests that multiple sleep factors, but sleep apnea and obstructive sleep apnea is one of the big ones, is a risk factor for developing any kind of dementia, actually. So it can increase your risk for Alzheimer's disease, it can increase your risk for vascular dementia, it can increase your risk for Lewy body dementia, or any number of different dementias.
And so what is the cause of this sleep apnea? Is it the sinuses, or is it, what causes that?
There's a number of factors that cause, so there's different kinds of apnea. There's central apnea, which is more of a deficit related to the central regulation of your breathing. But there's also, in the more common form, is obstructive sleep apnea, which could be something that's craniofacial. In other words, you might have smaller holes in your nose and your mouth. So that might be developmental. You see that, for example, a lot in individuals with Down syndrome. They have craniofacial feature differences that make them at greater risk for sleep apnea. But then also just soft tissue differences, like if you gain some weight, maybe you have, your tongue is particularly big in your mouth and it can fall back and collapse and close your mouth at night. There's a number of particular causes, but there's also a lot of treatments. And the number one treatment is positive airway pressure, or PAP treatment, whether it's a BiPAP, an AutoPAP, or a CPAP. And these machines can basically keep your airway open so you don't have those intermittent pauses.
So is it a lung disease, a lung issue here also?
Well, the lungs are definitely involved, certainly, but sleep is regulated by the brain. And so sleep, what will happen is that you'll get a pause in your breathing. The body will inform the brain that there's no oxygen, and the brain will wake up and try to get you to breathe more, right? And so your sleep becomes fragmented. And so you get the lung problems, you get the breathing problems, but you also get the oxygen starvation in all the different organs in your body. And you get fragmentation in your sleep. And both of those things independently can actually put you at risk for dementia.
Okay, interesting. And in our conversation previously, we talked about the circadian rhythm. So what is the impact, or how does that work in?
Sure, of course, yeah. So circadian regulation is really important. For some of you, for those that do not know what circadian rhythms are, they are a fundamental rhythm in our biology. They exist because we live on the Earth that's rotating on its axis and revolving around the sun. And so because of that, the earliest forms of light tried to avoid the UV rays, which damages DNA from those single cells.
Uh-huh.
So they evolved to learn to avoid it and predict when the sun was coming up and when the sun was coming down. And it propagated through all life. So you see it in all different organisms, plants, animals, everything. And they regulate very important chemical processes that occur in our bodies. About half of your genes that express proteins express a circadian rhythm, at least somewhere in your body. So this is a huge effect on your biology, right? And it count on a particular timing that certain chemical processes have to start at certain times of day, right? And if they don't happen at the right time, that can sort of create these organs that are not talking to each other in the right ways, and they're functioning not in the right ways. And something that happens a lot in our society is we have dysregulated rhythms. So there is now evidence that if you have an irregular pattern, like say you don't regularly sleep at the right time and get up at the right time, or you don't regularly do certain things at the same time or eat meals at the same time every day, that can actually confuse your body. It doesn't know what time it is. And that can put you at risk. A lot of these markers in your body that are associated with the proteins that are associated with Alzheimer's disease, for example, can increase if you have an irregular rhythm. And they become even further dysregulated if you get dementia and it progresses. So this is another fundamental feature, right? It organizes the biology of your body, and if it's not regulated appropriately by our behavior, then it can you're basically tricking your body to be jet lagged every day. And we know how we feel when we're jet lagged.
Oh, of course, it's like a sleepless night.
Yeah.
And so the idea then is to follow certain patterns, regular hours of sleep and waking.
Yeah.
So those people who are like night owls, who will stay up until whenever, they're actually throwing off their circadian rhythms.
That's a great question, actually. So there's a difference between irregular patterns and then regular patterns that have a certain preference. So you talked about owls, right? So there's owls and there's larks, right? And then one of the classic sayings in our culture is like, you gotta be the early bird, is the one that gets the worm, right? And you know, something that happens as we get older, we tend to become more larks. We tend to become less like owls. And this is counter to what we see in adolescence, where people tend to become more owls than larks. So there is some evidence that being an owl can actually put you at risk for certain things. Owls tend to be more likely to have mood or anxiety disorders than those who are not owls. But that doesn't mean that being an owl is necessarily causing that per se. But it's more if you have an irregular pattern, right? So different things are better for you in terms of health if you're an owl versus a lark, right? If you're an owl, you actually are more resistant to some of the behavioral effects of sleep deprivation, right? Because you tend to like to stay up later anyway, right? So if you take someone and you put a lark on a night shift, it's going to be really hard on their bodies compared to an owl. But that said, there's nothing worse than having a shifting pattern, right? The person where you have a day shift one day, you have a night shift the other day, you have a swing shift another day, right? If you keep rotating that, that's the worst thing.
That'd be a nightmare.
That would be a nightmare, yeah.
Oh, wow. Okay. So even patterns of irregularity done regularly. Is that what I hear?
That's right. Yeah.
Right.
As long as they're good for that person. And it turns out the owl and lark is genetically driven, actually. You have specific mutations in so every single cell in your body has a clock. And it's generated by the expression of certain proteins that then interact with each other, move out to the part of away from the nucleus of the cell, move out and interact with each other in the cytoplasm, then go back into the cell and inhibit their own expression. So this creates a feedback loop which sets a clock, and it happens at a certain time. Some people have mutations that make that clock run faster. Some have mutations that make that clock run slower. But that determines sort of preferences. You can see this in families. And we have specific genes that we know are associated with that.
All right. And so, but we still have an ability to influence those genes.
That's absolutely right, yes. And most people, owls and larks typically, can entrain to a normal schedule. There are some individuals that cannot. And those are the ones that have what we call circadian rhythm sleep disorders. And they're the ones that are the most affected by anxiety disorders or the most impacted by the way society is organized. And they have a lot harder time. They're just people who have these extreme preferences but then also cannot adjust to a normal schedule.
Right. Well, I know that there's a lot of people who are early risers,
Yeah.
and they will go to bed at 9 o'clock, you know, in the evening. And so, but I know a couple too. They have that kind of schedule, but they don't sleep at all. I mean, or an hour or two, and so they'll just give up at 5 o'clock, and they'll get up.
Yeah.
So they're not really getting much sleep. And so, like one, for example, she resorts to THC, the marijuana component.
Sure.
And so, but I've noticed that the people that do have THC regularly seem to be having a loss of memory. I don't know if there's any paper on that, or if that's just my personal observation or what, but I've known two people who have been, or at least two, who have been pretty heavy users. And their memories are really like borderline. So that's a concern. So in view of that, what is preferable? You know, to not sleep at all, or to take, you know, a drug, whether it's THC or maybe Valium. Sure. You know, so what's
that's the great conundrum, right? And this is something we've been struggling with for a long time in the field. Do you not treat their sleep disorder? Of course you should try to treat their sleep disorder. The issue is what approach you take to treat the sleep disorder. So these things you brought up are great, excellent questions about, you know, certain drugs may impact some people more than others, right? And, you know, some people may have a very intense anxiety disorder, for example, and that THC really calms them down and it helps them. And they can actually sleep when they have this drug, right? But the typical person who doesn't have that problem, if you take these drugs, their sleep is actually altered in a way that makes it less like natural sleep. The good news, though, is that there are other interventions that people can use to improve sleep. And the first line treatment, now, so the American Academy of Sleep Medicine now recommends that if you have insomnia, which is what you're talking about, right? These are symptoms that can't sleep, that the first line treatment that one should use is not pharmacology of any kind. It's actually something called cognitive behavioral therapy indicated for insomnia, or CBTI. So it's a special behavioral approach where you learn how to catch how you think about sleep, you catch what behaviors you use around sleep, and to try to adjust you to make sure that you enact behaviors that are kind of facilitating healthy, regular sleep.
Oh, sort of the emotional component.
The emotional component, the cognitive component, and more importantly, actually the behavioral component. What are our habits? How do we do things? Do we watch an angry pundit on TV before we go to bed, right? That's not good for your sleep, right? You know, do we engage in relaxing routines and behaviors? So sleep hygiene, these are examples of sleep hygiene, that's a part of it, but it's more than that. And you know, these people can seek help from you know, therapists who have been trained in these techniques, and then they can implement and learn about those techniques. There are some actually books they can even find and buy that describes those techniques. So if you can't find a therapist in your area, you can read these books and find out what are the techniques I can employ to try to kick this insomnia habit. So it doesn't help everyone, but it helps a lot of people, and it's been shown to be as effective as drugs with no side effects. So this is why people have been advocating for that more recently as a first-line treatment.
Because I am a hypnotherapist, and so I use hypnosis on myself and to help clients get over their insomnia. So I do often recommend also like binaural CDs, you know, where the music is repetitive and induces sleep. So what other ways are there? Please tell us.
So there are other methods that people can try right now that have been shown to be helpful for in the case of insomnia in particular. So there is now evidence that sort of meditative practices or mindfulness is really helpful for relaxation, and those can be very useful for improving insomnia symptoms. It's been shown in a lot of studies to be helpful for insomnia symptoms. There's experimental procedures that we're just trying out now that are sort of behavioral, and this is similar to what, I'm bringing this up because it's similar to what you talked about this sort of hypnosis and using the tones, right?
The tones,
So in experimental research, there's actually a method where you play something that's called pink noise, which is, it's different from white noise. White noise, you know, like those white noise machines where they play a constant noise that gets continuous, it doesn't change, and you habituate to it, and so you can fall asleep and relax on it. Well, it turns out if you have kind of a relaxing tone, but it's played at a specific rhythm, and if you time that rhythm to their natural brain waves. It can actually trigger more of those brain waves that happen during sleep, and they can align appropriately and facilitate more of them. You can have a deeper sleep. And this has actually been directly shown to improve memory. So if you take someone and you have the tones you played versus someone where you have like sham tones or you have tones at a different frequency, the ones that have the right frequency can actually improve their memory. If they study something, they remember it better the next day.
Okay.
So there's a lot of different ways that people are trying to play with this.
And how can one access those tones?
Right. So those tones are experimental, so there isn't a consumer device that's available yet. Though there are certain people who are trying to develop those on the market. So I think I would just say for people watching this, keep an eye out. In the next few years, these devices will start to show up. Now, there's some cautiousness that needs to be played when we think about that, right? Because all of the studies that have been done with this technology have been in, you study something, you give them one night of the tones, and you see what their memory is like. We don't know if it helps you every single night for years and years, and we don't know if you habituate to it or not, and we don't know if it'll help you with cognitive decline or not. This is something that people are interested in doing research on, but we don't know the answers to that yet. So it's not a silver bullet, it's just something that people are thinking about. I would certainly recommend something like CBTI for insomnia, or some sort of mindfulness practice, or interaction or integration of the two, for a treatment for insomnia.
Rather than going to
these tones or
whatever else.
Yeah, no, that's right. And actually, one of the issues of the pharmaceuticals, you brought up the THC for a couple of individuals anecdotally. There's actually been a number of different studies done on different kinds of drugs, and a lot of them show that whatever benefit sleep gives your memory, a lot of these drugs may help you go to sleep and stay to sleep, but they actually disrupt the memory benefits that sleep gives you. So this is because they actually alter the physiological fingerprint from your brain while you sleep.
Please say more about that, because that's really important.
Sure, yeah. So there's certain brain waves that your brain expresses. One of them is called slow waves, and they're called that because that's what they look like on an EEG trace. But they're these very tall, very lazy, slow brain waves that take somewhere between a half a second to a few seconds to finish, right? Being expressed. This is very different from how your brain is when you're awake. Now, these have to be expressed in a very certain way, in a very certain pattern. And certain drugs alter or disrupt how they're expressed, right? And it's been shown experimentally that if you enhance these waves, it can improve memory, right? And there's been a lot of studies that shows that these slow waves, which are basically the fundamental brain wave associated with deep sleep. So the more of those you disrupt, the less deep sleep you have, or the more disrupted your deep sleep is, or the less memory benefit you get from your deep sleep. So this is why we have to think about new ways of approaching the problem. And a lot of companies that are thinking of developing new drugs now have to start thinking beyond, well, does it keep you asleep? Or do these drugs keep you asleep and not suppress those slow waves? You need to go beyond that to, do they facilitate the expression of them in an appropriate way? Yeah,
because those consequences seem too
important,
too important to dismiss. Because I do know two people actually who have been taking some kind of medication. It's a prescription drug, one for 15 years.
Wow.
And there's, I know there's some imbalance, and there is a tremor in one. So, and I just wonder, I would never comment on it, but I just wonder if it's related to the drug.
It's hard to know, and there's just really not that much data out there on the use of these sleep aids long term. And the idea behind treatment with sleep aids is actually to use them, if you do use them in a short term to aid other therapeutic interventions, and to try to keep people from staying on them for the rest of their life. That said, there are some individuals where it's really important to treat their sleep, and that's the only thing that works. And so it's always going to be a conversation with that patient and their doctor. And it's particularly helpful if they have a sleep disorder that they see a sleep medicine specialist, someone who's board certified in sleep medicine.
Right, because, the other question that I had is, yes, the hormonal shifts, but what about those environmental factors like the smart meters, like the smartphones, the Wi-Fi? All of that has an impact,
it does.
Would assume.
You're absolutely correct. It all has an impact. And this partly is we get back to those rhythms, right? So our cells in our bodies are all synchronized by a particular clock in our brain, and that receives direct input from our eyes. where we have special cells in our eyes that detect the green blue light levels. And this is why things like computer screens or smart devices or iPads and all of those things can be disruptive to our sleep, because we're exposing our eyes to blue and green light later than our body expects it. So our body responds to that, right? Because our body likes to predict things and it likes to be accurate when it predicts things. This is why we can recover from jet lag, right? You fly to a different place, you're seeing light when your brain doesn't expect it, then you shift your patterns.
Correct.
But if you're doing that in your own zip code every day and every night, your body's constantly trying to shift. So one of the things that's recommended is to try to minimize blue-green light at night in the evening after the sun is setting. You can do a lot of things for that, though. You can get a red night light, for example. So I'm not telling people that they need to go to the bathroom in the dark. That's not a good thing, right? Because you have to avoid falls and everything, which is very bad. But you can get a red night light that's bright enough that you can see, and that your clock will be a little bit more blind to. Yeah. Right. You can also, for your screens, whether you have a PC or a Mac, there are different programs that can basically make the light coming off of it more of the red, yellow, and orange spectrum and less the blue and green. They're on your phones. There's even apps that are free that you can download that you can add to your phones that will do that as well. So these are ways that we can try to deal with that. But the other thing is to try to engage in behaviors that expose you less to that light at all. Maybe you want to do a little reading instead of watching the TV, for example.
Right, and get outdoors.
And get outdoors and expose yourself to a lot of light during the day. Be very active during the day. Make sure that the meals that you eat, that your biggest meal of the day isn't dinner right before you go to bed. That's also not very good for you. So all of these things help tell the body, oh, it's this time of day versus that time of day.
Right. But those frequencies or brain waves from the Wi-Fi, and now we have 5G coming, so that's a concern.
Yeah, I know nothing about the physiology of that. I wouldn't say that there's enough evidence in the literature to suggest that these Wi-Fi things are going to directly impact your brain waves per se. But it's just better in general to be as unplugged as you can before you go to bed. Do something that's relaxing. Make sure that you don't expose yourself to a lot of these bright lights and everything.
And exercise,
eat well, all those good things. And they all interact, they help each other. Exercise, your sleep is better.
Well, Dr. Mander, it's been a pleasure. And as I said, time flies when, when we're in front of the camera. So thank you so much for being with us. And I appreciate your participation. And I know that people will be eager to hear more about sleep disorders. So when you have the time,
absolutely,
I would love to have you back.
Thank you, Renee. It's been a pleasure to be here.
It's been a pleasure.
Can I say one more thing?
Yes.
So we're doing a lot of studies at UCI.
Yes.
And we're interested in how sleep changes with age, but also how it relates to Alzheimer's disease and cognition. And so we are plugged into UCI Mind's C2C registry. So if people want to learn about our studies and find out and get plugged in, they can go to the letter C, the number 2, the letter C. You just look up the C2C registry in Google and search for that. Then you'll find us and you can go in there and sign up. So we really love people to get engaged because we can't do this without them.
I know Dr. Yaza had given me a flyer to pass around to see if anybody wanted to participate in your studies. And I, for one, have already volunteered.
We can't do this without you guys. I mean, and this is how we advance as a community.
Again, thank you for being here and participating. And thank you so much to my audience for watching.